Hello everyone, this is part E of experiment 1 where we have tried to make different modulo n counters using the master reset pins. So first of all we have this leftmost circuit wherein we have connected the first reset pin, that is MR1, to A1, and the second reset pin, that is MR2, to A0. So therefore the first instance when A1 and A0 both become 1 simultaneously, that is both of them attain the high state simultaneously, MR1 and MR2 both will become 1, or that is they would reach the high state and the counter would get reset. So the first instance when this happens is at binary input 0 0 1 1, that is equivalent to uh, 3 in the decimal system. So as soon as this counter reaches 3, it gets reset to 0. So therefore we would get an output of 0 1 and 2 in this particular circuit, therefore modulo 3. Similarly, we have made a modulo 6. I have made a modulo 6 circuit over here, wherein I have connected MR1 to A2 and MR2 to A1. So the first instance, when both of these pins simultaneously become 1 or reach the high state, is at 0 1 1 0, which is equivalent to 6 in the decimal system. So therefore this would be a counter which would go from 0 to 5. So therefore a modulo 6 counter. Similarly, a modulo 9 counter wherein MR1 is connected to A3 and MR2 is connected to A0. So the first instance when both of these pins simultaneously become 1 or reach the high state is at a binary input 1 0 0 1, which is equivalent to 9 in the decimal system. So therefore it is a modulo 9 counter. So we would just simulate it, and first of all we look at the left circuit. So it goes from 0 1 2 and then again 0. Similarly, a modulo 6 counter, it goes from 0 1 2 3 4 5 and then again 0, and then this continues. Similarly, a modulo 9 counter where we see that it is going from 0 to 8, and then again it gets reset to 0. So the moment it reaches 9, it instantly goes back to 0 again. So therefore it is actually counting from 0 to 8. So this is a modulo 3, modulo 6 and a modulo 9 counter. Uh, I have also made a modulo 7 counter. So uh, to make a modulo 7 counter, we need to ensure that as soon as the binary input reaches 7, that is 0 1 1 1, the master reset pins need to be connected in such a way that both of them become high or reach the high state simultaneously. So since there are only two pins here and there are three inputs over here which would be at the high state, since it is 0 1 1 1, so therefore I have used an AND gate over here to connect A0 and A1. So if both of them are 1, this would give a high output which is connected to MR2, and MR1 is connected to the third high input, that would be A2. So as soon as this input reaches 0 1 1 1, that is 7 in the decimal system, the system would get reset to 0. So effectively it would be counting from 0 to 6 and therefore a modulo 7 counter. We would check that. Now we also see that in the middle there are a few uh, random characters getting displayed. This is visible effectively when we are reducing the speed of simulation. If we uh, if we increase the speed of simulation to, let's suppose, uh, 10 seconds, then we see that this difference is not visible. So the random characters being displayed in the middle is something that was observed to be a fault in the simulation software itself. So that is something that can be ignored. So therefore here we have a modulo 7 counter. So this was the end of part E of experiment 1. Thank you.